In this video we will solve question number 35. Okay, here s equals to x comma y belongs to R2 and x greater than 0, y greater than 0. That means s is first quadrant of xy plane. Okay, and f is a function such that s to r. Okay, and r is a real number, and fx comma y is defined by this 2x square plus 3y square minus log x minus 1 by 6 log y. Okay, and then which of the following statements are true? Option number A is there are a unique point in S at which fx comma y attains a local maxima. Okay, there are unique point, only one point of local maxima. And option B is there is a unique point in S at which fx comma y attains local minima. Okay, first with derivative f with respect to x. Okay, partial derivative. Okay, fx is equals to 2 is constant, so derivative of x square is 2x. Okay, for partial derivative y is 0, so partial derivative of y square will be 0 and 3y square will be 0, so plus 0 minus derivative of log x is 1 by x minus 1 by 6 into log y. Derivative of log y will be 0 because our derivative is partial derivative, so this equals to 4x minus 1 by x. Okay, and now we will derivative f with respect to y, partial derivative. This equal to derivative of 2x square will be 0 plus 3y square. 3 into derivative of y square is 2y minus derivative of log x will be 0 minus 1 by 6 into log y. Derivative of log y is 1 by y. Okay, so this equals to 6y minus 1 by y, 1 by 6y. Okay, now I will derivative again this fx. Again I will derivative this with respect to x. So fxx equals to 4 is constant, derivative of x is 1 and minus 1 by x. Derivative of 1 by x is minus 1 by x square. So minus into minus, it will be plus 1 by x square. Okay, and now I will derivative again this. This implies f y equals to derivative of 6y is 6 minus 1 by 6. Derivative of 1 by y is minus 1 by y square. So minus into minus is plus. Okay, and now I will derivative again this fy with respect to x. So this implies fxy equals to, if you derivative this is function of y, so if you derivative partially this, then the result will be 0. Okay, so this implies fxx into fyy minus fxy square. This equals to 4 plus 1 by x square into 6 plus 1 by 6y square. 6 plus 1 by 6y square. Okay, and minus fxy is 0. Okay, so this is positive, this is positive. That means this is positive. That means there will be a either maxima or minima. Okay, so find the maximum point, maximum or minimum point. It means extreme point. For find this maximum or minimum point, I will put fx equals to 0 and fy equals to 0. For fx equal to 0, this implies fx is 4x minus 1 by x equal to 0. So this implies x equal to plus minus 1 by 2. Okay, and fy equal to 0, this implies 6 plus 1 by 6, y equals to 0. So this sorry, not y square. Okay, so this implies y equal to 1 by 6 plus minus 1 by 6. Okay, but this is not plus minus, this is only plus, because the reason is x and y are coming from domain. Okay, they are coming from domain, and here in this function f, a domain is s is a domain, and in the set s set, x is greater than 0 and y is greater than 0. So not plus minus, only plus. Okay, therefore the stationary point is 1 by 2 comma 1 by 6. Okay, there are only point of either local maxima or minima. Sorry, it is a stationary point, it's extreme point. There are only one extreme point, unique extreme point. Okay, and at this point the function f is maxima or minima. It's I will check. Okay, so let's check. F x equals to x-axis is 4 plus 1 by x square. So this equals to 4 plus 1 by x square. Okay, and this is always positive. Yeah, and fyy is 6 plus 1 by 6 y square. Okay, this is also positive. If f(x) is positive, then automatically fyy is positive. Fyi is positive, then automatically f(x) is positive. Okay, and f(x) is positive, that means f(x) is positive, that means the point half comma 1 by 6, at this point the function f has minima. Okay, it will give minimum value. Okay, so first option is incorrect, because the option is there is a unique point in S at which fx, y attains a local maximum. There are no maximum point, only minimum point. So option A incorrect. Okay, and option B is correct, unique local minimum point. Okay, and next option C. For each point x0, y0 belongs to S, the set x, y belongs to S such that fx, y equals to fx0, y0 is bounded. And in option D, it's given that it is the set is unbounded. The set is unbounded. Okay. Okay. Suppose this is origin, this is x-axis, z-axis, and this is y-axis. Okay, suppose this is the function fx comma y. Okay, this is z equals to fx comma y. Okay, and this point half comma 1 by 6 is the minimum point. That means this point will be here, half comma 1 by 6. Okay, because it's a minimum point. The graph is not like that, because if the graph will be like that, then this is a maximum point and there are no maximum point. Okay, if this graph will be like that, then this point also a minimum point, but there are unique minimum point. This is the unique minimum point. Okay, and the minimum point is only this. Okay, that means the graph will be like that. Okay, the graph will be like that. Okay, it's a 3D figure, huh? Okay, and in question, what is the set? This is the set. The set is x comma y such that x comma y is belongs to S. X comma y belongs to S, and fx comma y equals to f x naught comma y naught. Okay, what is fx naught comma y naught? Suppose a plane z equals to fx naught comma y naught. Okay, suppose the plane is this. This is z equals to fx naught comma y naught. Okay, okay, and this plane cut this graph z equals to fx comma y. Okay, then there will be a plane. Okay, if you take the projection of this graph, the 3D graph in 2D plane, then it's look like this. Okay, it's look like this. This is x-axis and y-axis, and the graph is z equals to f x comma y, and the white straight line is the plane z equals to f x naught comma y naught. Okay, listen, the straight line cuts the graph at only exactly 2 points. The cut points are only 2 points. The cut points are finite number. Okay, so the planes this plane z equals to 1 minute. This plane z equals to fx naught comma y naught cut this curve z equals to fx comma y at only 2 points. That means there are a bounded solution. There is a bounded solution. Okay, for each x naught comma y naught belongs to S, the set is bounded. Okay, if the set is if the set is unbounded, then there will be infinite number of cut points. Okay, so the number of cut points is bounded, number of cut points is finite, then the solution will be bounded. Okay,